All right, welcome back. We are up to lesson 10 now. Let's go straight to the examples. So the point P on the unit circle has coordinates 1, 0. For each angle of rotation, state the number of rotations defined by the angle and then identify the coordinates of P after the given rotation. So let's go back to our notes for a second. Okay, remember each rotation is approximately 360 degrees or 2 pi radians. So whenever I go make one full rotation around the unit circle, that would be 2 pi radians. So one rotation is 2 pi. Two rotations, meaning going around the circle twice, would be 4 pi. Three rotations would be 6 pi, so on and so forth. The key fact is that each rotation, each full rotation of the unit circle is 2 pi radians. So to figure out the number of rotations, all I'm going to do is I'm going to take the angle. I'm going to take the angle and I'm going to divide it by 2 pi. So if I want to figure out the number of rotations, I'm going to take the angle and I'm going to divide it by 2 pi since each full rotation is 2 pi. So that's why, all right, if we go to Desmos, 3 pi over 2, okay, I know the answer is there, but I want to explain to you where they got that from. If I take 3 pi over 2, and I'll put that in parentheses, okay, and I divide that by 2 pi, I get 0.75. All right, so 3 pi over 2 is 3/4 of a full rotation. All right, so on the unit circle, 3 pi over 2, that's why we say 3 pi over 2 is always down here. So that's what we're going to do for all of these. To fill in this first column, we're going to take the angle measurement and we're going to divide it by 2 pi. So the next one is 25 pi over 12. So I'm going to change this to 25 pi 25 pi over 12. Okay. So 25 pi over 12 divided by 2 pi. So that's going to be approximately 1.04 rotations. So 1.04 rotations. So that means you go around the circle once and then you go a little bit around a second time. So the next one is 5 pi over 2. So we're going to change this to 5 pi over 2. So that's 1.25 rotations. So 1.25 rotations. Okay, so what that means, that's 1.25. So 1.25 rotations means you go around the circle one full time, and then I'll change the color and I'll go around 1/4 more and I end up here. So I go around the circle one full time plus an extra quarter. Okay, so that's what that means in terms of rotations. All right, so the next one is going to be 7 pi over 3. So in Desmos, I'm going to change this to 7 pi over 3. So we'll call that 1.17 rotations. Okay. 49 pi over 12. So 49 pi over 12 is 2.04 rotations. So that's interesting. So that means you go around the circle 2 full times and then plus a little bit a third time. Okay, and then the last one is 5 pi. So this will be 5 pi. So that's 2.5 rotations. So 5 pi is 2.5 rotations. Okay, so that's how we find the number of rotations. So now to fill in the next two columns, we want to find the coordinates. So the horizontal coordinate is your x value. The vertical coordinate is your y value. And remember, we've established this before, that your x value is the cosine of the angle. The y value is the sine of the angle. So to figure out this column here, I'm going to find the cosine of the angle. And then to fill out this column here, I'm going to find the sine of each of these angles. Okay, so that's where they got the 0 from, is they did cosine of 3 pi over 2. And then -1, they did sine of 3 pi over 2. All right. So for the next one, 25 pi over 12. So if we first want to do cosine of 25 pi over 12, and then we want to do sine of 25 pi over 12. So that will be 0.97 and 0.26. So 0.97 and 0.26. Okay. 5 pi over 2. So we'll just change these angle values to 5 pi over 2. All right, so that will be 0 and 1. Okay, 7 pi over 3. Okay, again, we'll just change the angle measurements to 7 pi over 3. So that will be 0.5 and 0.87. All right, 49 pi over 12. Whoops, 49 pi over 12. So 0.97 and 0.26. All right. And 5 pi. So -1 and 0. Okay. Okay. So that's it for number 1. Okay. In general, if theta is greater than 2 pi radians, explain how you could use the unit circle to make sense of cosine theta and sine theta. So in general, if theta is greater than 2 pi radians, explain how you can use the unit circle to make sense of cosine theta and sine theta. Okay, so I'm going to give you this answer verbally instead of writing it down. But we talked about if an angle is bigger than 2 pi, that means it's going to be more than one rotation. So notice all of these except for the first angle, all were more than one rotation, which means you made at least one full revolution around the circle, and then you went a little bit extra. Okay, 0.04, 0.25, so on and so forth. In the case of the last two, you made 2 rotations and then went a little bit extra. Okay, so the cosine and sine are going to be the same at those angles bigger than 2 pi than they are at that little bit extra. Okay, so for example, for 25 pi over 12, going 1.04 rotations means I go around the circle one time, and then I go 0.04 around a second time. So that's just a teeny tiny bit the second time, because a quarter would 0.25 would be up here. So it's going to be about there, roughly. Okay. So the cosine at that spot right here is going to be the same at 1.04 rotations as it would be at 0.04 rotations. Notice 1.04 and 2.04 rotations had the same cosine and sine values. So it doesn't matter how many times I go around the circle first, the cosine and the sine is going to be the same as if I just went around that little bit extra the last time. In this case, that 0.04. Okay. So that's what happens if your angle is greater than 2 pi. It just means that the cosine and the sine of that bigger angle is going to be the same as if you had just gone around that last little bit. Okay. To show you one more example, I'll do 5 pi over 2. That might be a little easier for some of you to visualize. So 5 pi over 2, we said, was 1.25 rotations. So that means I go around the circle one time, one full rotation, and then I go a quarter of a rotation after that. So there's your 1.25, and I end up here. Okay, so the cosine at that angle, 5 pi over 2, is the same as if I had gone 2.25 rotations or 3.25, or it would have been the same as if I had just gone 0.25 rotations. It doesn't matter. The cosine and the sine is going to be the same as if I had just gone that little bit extra, in this case, that 0.25. Okay, so that is it for this lesson.